Okay, we're going to talk about dividing polynomials. I'm going to give you a couple different types of problems. What we're going to see in the first problem is you're dividing by a monomial. So what I want you to do is to copy this down in your notes and then underline and highlight. And notice that anytime you're dividing by a monomial, this is simply all you have to do. You're going to separate this big fraction into three little fractions. And then you're going to reduce it like we would reduce back problems in 6-1. So let me show you what that looks like. So the first thing we want to do is take this and put it over 3ab. Okay, then you want that plus sign. And then take 6a cubed b squared all over 3ab. And then the last fraction, 18ab over 3ab. Then each of these become their own individual problems. And you're just reducing. So the 3's cancel. Then you have a squared over a. So this is a to the first. You're subtracting and you get an a and you write that answer on top because the 2's larger. The b's cancel. So all you have left on that answer is an a. Now the middle one. 6 divided by 3, 2. A cubed over a the first. You're going to subtract and get a squared and write it on top. And then this is b squared over b the first. Subtract and you get b to the first. And the last one, everything cancels on the a's and the b's, and you divide this out and get 6. So the answer looks like this. So when you're dividing by a monomial, split it up into individual problems. Let's do another one like that. So here's the top. So you're going to rewrite it. Bring 5a squared b, put it all over 5ab. And then minus, see that minus right there? So put minus. And then 15ab cubed all over 5ab. And last, plus, see the plus right there. And then 10a cubed b to the fourth all over 5ab. Okay, let's reduce. So this one, you're going to be left with an a squared over a the first, but the 5's cancel and the b's cancel. Put the minus here. 15 divided by 5, 3. The a's cancel, and you got b squared. And then this, you get a plus 2. You're going to get a squared, and then b to the third. Now, I know all of my answers for my two examples, they end up looking like these. Don't be afraid if some of these turn into fractions or stay as fractions, because I know you split them up and you made them into fractions to begin with, but these all turn back into non-fraction answers, but you could have one of them be a fraction answer, and that's okay. So don't panic, and check your odds in the back as you do those, because there's a lot of little places you can make mistakes. Okay, now the second type of problem is when you're dividing by a monomial, and you're going to use what's called synthetic division. So let me let you copy this stuff down. And then I'm going to show you this problem. It's very particular. It has a little bit of a feel of matrices to it because it's a certain particular order and you do this certain things. So watch me do this first one. Maybe you want to pause and rewind and watch me do it again. And then I've got a couple more examples after this one. It's really easy, but there's a lot of details that you need to pick up on. Okay, this is the guy that came up with it. It only works when the divisor is a binomial. So underline and highlight that. So you use synthetic division when you're dividing by a binomial. And it has to be in this form, x minus r. And that'll be clearer when I show you the first example. So here's this. You got this big long polynomial being divided by a binomial. See that? So what we want to think about is, can I fit it back into an x minus some number? And it fits perfectly. So what you're going to do is you're going to set up this problem by using r is a 2. So what you're going to do, notice it's in parentheses, you're going to pull that number out and you're going to change that sign. So you want to work with a positive 2 whenever your divisor is an x minus 2. I'll do some others where they're like x plus 1 or some other sign change. And you'll see you just switch the sign. That's what you do. Now, you also need to be able to locate the coefficients on all of these. We're not going to be working a lot with the variables throughout the problem. You only work with the coefficients. So let me show you what this looks like when you set it up. So you do this strange little backwards box. It reminds me of an upside down division symbol when you're doing long division. You do this little corner thing. You put this as the positive 2. It goes here. And each of these are the coefficients from the polynomial. See, there's a 1, negative 2, positive 1, negative 3, and a positive 2. But after you set that up, you want to skip a row on your paper and then draw a line all the way across. And then one more thing you need to do is on the very last number, put this little line. That is going to tell us the remainder. Okay? Let me show you the process. This works every time, same movement. So watch what I'm doing. After you get the problem set up, you go to that first coefficient, in our case it's 1, and you drop it down. Okay, easy enough. Just got to remember that's where you start. Then you're going to multiply. 1 times 2, 2. You want to write it right here underneath the next one in line. And then you want to add these up. That gives you a 0. And then you're going to take this 0, multiply it by the 2 again, then you get 0. Add, do it again. 1 times 2, 2. Add, multiply, negative 1 times 2, negative 2. When you add those, you get a 0. And this means that you do not have a remainder. It goes in evenly, if you want to think about it that way. Now, to you and me, this looks like 1, 0, 1, negative 1. It sounds like binary, you know. It's a little weird, but it's actually telling you your answer. And the answer is coded. What you have to do is you have to go back and you have to look, what was the highest degree that you saw in the polynomial? Well, it was a 4. So you start with this, and so that means you go 1 less. So if that up there said x to the 7th, you would start with a 6. Now, there's a 0 here. I'm going to put it in this one time, and then I'll show you how the final answer actually will look. It starts going down by 1 each time. So the next one, since I have 0x squared, the next one will be 1x, and this is just the constant. Remember, that's the remainder. Now, the back of the book wouldn't write your answer like that. They don't put the 1, and if the coefficient was 0, they won't even put that on there. And again, they won't put the 1. And so this would be the final answer when you divided this problem out. This is the answer you would see in the back. So I know that's a little bit crazy, so I'm going to do a couple more examples to show you. So next one. Let me show it to you. See if you can start writing out what it should look like. Let's start with, what's the R going to be? So go look at the divisor. It says x plus 1. Are we going to use 1? No. We're going to use negative 1. Okay? So you're going to use negative 1. And then I want to point out, we have x to the 4th, that's a 1. There's x cubed, that's a negative 2. Wait a second. They skipped a term. They skipped the x squared. If they ever skip a term, you have to fill it in with a 0 or it's going to mess you up. So we need a 0 about right in here, and then another 1, and then a negative 1. So look at how I got it set up. So 1, 1, negative 2, negative 2, 0, because no x squared, 1, and then a negative 1. So it's set up. Once you got it set up correctly, then go to work. So here we go. Okay, remember the procedure. You start with the first coefficient, drop it down. So first one, drop it down. Multiply, write it down, then add. Okay? Multiply, add. Multiply, add. Multiply, add. Okay. Now, this is a remainder. And I got to show you how you write your remainders. I'll do that because I've got to write the final answer. Don't ever leave your synthetic division looking like this because it's not explaining the answer. You've got all the information, you just need to know how to write it from here. So we're not going to start with x to the 4th. You're going to start with x cubed. And you can put the 1 on there if you want to. The back of the book will not do that. And then you're going to do minus 3 Remember, you're going to keep going down. So that's x to the second. And then the next one is a plus 3x minus 2. So that's completed. But how do we do the remainder? So everybody watch how you do this. Okay, you need to put a plus. You need that 1. And you write it as a fraction. Now this is huge. Put the remainder value here, but what goes underneath is your divisor. So whatever was the divisor has to sit underneath that fraction. And so this will be your answer. What's really nice about synthetic division, it doesn't take up a whole lot of space. And the math isn't terribly difficult. But you've really got to know, pull this down, multiply, add, multiply, add, multiply, add. So you kind of got to keep that straight. Okay, let's do one last one. I think maybe you guys will have it. Okay, so we got a minus 1. By the way, it doesn't matter if it's a's, b's, y's, z's. It doesn't matter. Just think about it as those are x's if you want to. So the number I'm going to put here, change that sign. Now let's look up here. A cubed, a squared, a, not skipping anything, but there's no constant. I do need to put a 0 at the end of this, so remember to do that. So I need a 2, -1, -4, and a 0. Draw the line, put that little box to remind me that that last number will be my remainder. Okay, so if you can remember, pull the 2 down, multiply, add, multiply, add, multiply. Okay? How do we write our answer? This one, the highest was a to the 3rd power, so we're going to have a to the 2nd power, plus 1a minus 3, and then there's a couple ways to write this. I like doing the plus with the fraction -3 over a minus 1. I'm going to show you there is a variation. The books sometimes might do this variation. They may go and say minus 3 over a minus 1. Okay? And I just want you to see, if you see that in the back, you're not confused why they're doing it. Those are both correct. They're the same thing.